We have already made a single episode about complete knowledge of vertical curves. However, for the viewer's convenience, we have split it into 3 parts. The links to that complete episode is given in the description. If anyone wishes to watch that, they can choose from the description. This episode is part 2 of 3. In this episode, we will see the derivation of important formulas by using the algebraic formulas of parabola, such as the derivation of formula for curve length, and for the constant value of k for rate of change of grade, and finally, for the tangent correction h. We will review all this in less than 10 minutes time. So, please watch till the end. Welcome to Civil Guru. These videos made in different languages, like English, Hindi, Tamil, and also in Arabic now. Please choose your desired language from our playlist. If you like this video, please like and subscribe now. Now, we will see how to get the length of the vertical curve, which is denoted as L. The length of the vertical curve can be obtained by dividing the algebraic difference of the 2 grades by the rate of change of grade, with due consideration of sign of the grades. That is, the length of curve L equals to total change of grades divided by the rate of change of grades. That is, G1 minus G2 divided by R chains. Here, the G1 minus G2 equals algebraic difference of the 2 grades in percentage, and R equals the rate of change of grade in percentage per chain. The standard intervals are considered as 1 chain. Now, we will see what type of curve can be used as vertical curve. Either a circular curve or a parabola may be used as a vertical curve. In a parabola which is having a vertical axis, the rate of change of grade is uniform throughout the vertical curve. So, the parabolic curves are used as vertical curves. Here, we have to remember our school days and recollect our memories regarding the equation of parabola. The general equation of a parabola with a vertical axis y is ax square plus bx. The slope of the curve at any point, that is, dy by dx equals 2ax plus b. And the rate of change of grade r equals to d square y by dx square. That equals 2a. And this 2a is a constant. Now, let us see what is tangent correction, and how it helps to design a vertical curves. In vertical curves, all distance along the curves are measured horizontally. And all the offsets from the tangents to the curve are measured vertically. The length of the curve is its horizontal projection. Please look into this sketch carefully. In this sketch, the OX and OY is the axis of the rectangular coordinates, passing through the beginning of the vertical curve, O. And OA is a tangent line, having the grade of plus G1% of slope. And AB is the tangent line, having the grade of minus G2% of slope. And OB is the vertical curve, produced by the method of parabola. Now, let us mark a point on the curve, having the coordinates of x and y. And name that point as Q. And let us draw a vertical line, PQR, through the point Q. Here, the length of PQ is the vertical distance between the tangent and the point Q on the curve. And it is known as the tangent correction of vertical curve. And it is denoted as h. Now, let us find the value of h. This h equals PR minus QR. Here, the value of PR equals G1 into x, and QR equals y. Now, PQ, that is h equals G1x minus y. Here, G1 is slope in percentage. And x is the horizontal distance, or the number of chord, n measured from the beginning of curve. Now, we will find the value of this y by using the equations of parabola. That is, y equals ax square plus bx. And dy by dx equals 2ax plus b. Now, at the beginning of curve, at point O, the value of x equals 0. In that case, dy by dx equals plus g1. We already knew that dy by dx equals 2ax plus b. Here, when the value of x equals 0, then g1 equals to dy by dx. That is equals to 2a into 0 plus b. Finally, g1 equals plus b. Let us substitute this value of b in the general equation of parabola to find the value of y. That is, y equals ax square plus bx. Here, the value of b equals g1. That means y equals ax square plus g1x. If we do the reciprocal of these values, then minus ax square equals g1x minus y. We already knew that the value of g1x minus y equals h. So, the value of h equals minus ax square. Here, a is a constant. In vertical curves design, this constant is denoted as k, so we can call this as h equals kx square. X is the horizontal distance in algebraic formulas. So, x can be replaced as n. Because n is the total number of chords with uniform intervals, counted from point O, which covers the total length of curve L. Finally, this can be marked as h equals kn square. The difference in elevation between a vertical curve and a tangent to it varies as the square of its horizontal distance from the point of tangency. This difference in elevation is known as the tangent correction. Now, we will derive a formula to find the value of k. Extend this tangent of grade g1 up to c, which is vertically above point B. Now, let us draw a horizontal line until it meets at point D in the line of BC. And let us draw one more line vertically, starting from the point of apex, A, which is passing through the middle of the curve, connecting the points F, E, G. Now, let us assume the length of the chord at uniform intervals is L. The number of chords at each side of the grade is n numbers. So, the distance between the starting point of O to the midpoint of E is n into L. That is equals nL. Similarly, from the midpoint of E to the endpoint of B also nL. So, the total length of vertical curve L equals 2 into nL. That is 2nL. And total number of chords in this vertical curve, that is n equals 2n. G1 and G2 equals grades of two tangents. And E1 and E2 equals corresponding rises or falls per chord length L. Now, let us do some algebraic calculation. That is, OA equals AC. And CD equals n into E1. That is, NE1. And BD equals minus n into E2. That is, minus NE2. Now, CB equals CD plus DB. That is, NE1 plus minus NE2. That is, n into E1 minus E2. Here, at the end of the curve, CB equals to H. We already knew that H equals Kn square. Here, n equals 2n. That means Kn square equals k into 2n square. That is 4kn square. Finally, CB equals 4kn square. That is equals to n into E1 minus E2. Now, k equals n E1 minus E2 divided by 4n square. Here, this n and square of the n gets cancelled. So, finally, k equals E1 minus E2 divided by 4n. In the above equation, proper care for signs must be taken while substituting the numerical values of E1 and E2. If you like these videos, please subscribe now and share with your friends. And also don't forget to press the bell button. Thank you.